so concerned.
Because this Chromebook sucks. It like won't turn on.
So we're going to be looking at 9.5, the last section in this chapter. It's about geometric series. So similar to yesterday, or if you didn't get a chance to see that lesson yet, series is is a list of numbers that you're adding together. So we're looking at a geometric series where basically the list of numbers we're adding together has a common ratio, that something that's multiplied by. So getting started, this first example, it says the soldier's reasonable request. It says a famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. The soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, then 4, then 8, and so on for all 64 squares of the chessboard. The king decides that the request is reasonable. Let's see how reasonable it actually is. So, according to the story, what would the first 5 terms of this series be? And then, kind of obvious from the lesson title, is it arithmetic or geometric?
Arithmetic.
It's probably going to be geometric if that's the section with your what is your cactus. All right. So let me turn my pen on. So you would be, your first term would be 1 kernel. Your second term would be 2. Your third spot on your chessboard would be 4. Your fourth place would be 8. And your fifth place would be what? What's the pattern?
16.
So it's
Wait.
right?
Yeah.
So it probably doesn't seem that unreasonable right now because all the numbers are pretty small. We're going to see this gets quite large if you did it for all 64 squares of the chessboard. So, okay. So we're going to actually find it using this formula. One thing before we actually calculate, one note I want to make. There's 2 formulas to find a geometric series. The reason there's 2 formulas is because sometimes you'll have different pieces of information. Like sometimes you might know the number of terms, sometimes you might not. Sometimes you might not know the last term in a series. Maybe you don't know how big it will get. Like in this case, we don't know that yet. So this first formula is you use this one when you know n. The second formula you use when you know a of n, or the last term in your sequence. Like how big does it actually get? So that's kind of the distinguishing factor. So if these formulas look scary, like when do you use each one? That's kind of the big idea. But basically, if you know your n, use the first one. If you don't know your n, use the second one. But going back to this problem, we're going to be using the first formula because we actually know our n. There's 64 places on a chessboard. So we're going to write, if you look in this formula, there's really 3 kind of variables in the formula. There's A1, there's n, there's r. So there's kind of 3 pieces to this formula. Why am I writing that? Probably from yesterday, I have it. So n and r. So A1, our first term in this series was 1. We started with 1 kernel grain. Our n is going to be 64 because there's 64 places on the chessboard. And then the r, what was our ratio? What was our series going up by? Like what was the geometric ratio between each number? What were we multiplying by? 2. So we're going to plug this into this formula, this first one here. So we would have S of 64, because we have 64 numbers we're basically taking the sum of. It would be A1, so 1 times 1 minus our R up to the nth power. So 2 up to the 64, which is going to be pretty large. 6 times 2, 64 times. And then 1 minus our r on the bottom, so 1 minus 2 on the bottom. So I don't know if you guys have a calculator handy. One thing you do want to be careful when you're plugging these in your calculator is I usually kind of work out the top first, press equals, and then I divide by the denominator. It might be kind of tough to put everything in at once unless you use a lot of parentheses. Let me see. But I plugged this in. I don't know if you want to verify. It's definitely possible. But you get something that's like, it doesn't fit. It overloads your calculator, so it gives you scientific notation. So it's 1.84 about times 10 to the 19th power. So even though his request might have seemed pretty reasonable, it actually turns out that's a lot of grain.
Nyla said let her in, please.
What'd you say?
Nyla said let her in, please.
Oh, sorry. I just saw her. She's okay. Yep, she should be joining here in a second. All right, so that's our first example. Basically, we're going to kind of look at some more. We'll see some of these problems will use this first formula. Some of them will use this second formula. So I don't know if you, I'm assuming most of you guys probably don't have this printed out, but one thing you probably want to write down, because it might not be on the screen, is write down these two formulas, or even know those. I'll give you a second if you need to do that. But basically, we'll just look at some problems, just finding the sum of finite geometric series. So all these series we'll be looking at have a beginning and an end. At the end of this lesson, we'll be looking at a series that kind of go on forever. Kind of how to handle those. Okay. Everyone okay?
Mhm.
Try and keep up the formula at least for these first two. All right, so looking at example A, notice they give us A1, they give us R, and they give us N. So we want to use this first formula because that's the formula you use when you know your N. Smiley face. So we're just going to plug in what we know. So we're going to do S. Oh, turn my pen back on. So S of 6, because we have 6 numbers we're adding up together. A1, so in this problem, negative 15 times 1 minus our R. So in this case, negative 2. If it's a negative, you want to put parentheses around it for sure. Like, it's probably always a good idea, but definitely negative numbers. Up to the 6th power, all over 1 minus R. So 1 minus negative 2, or if you want to write that as just 1 plus 2. From here, you just put in your calculator. Like I said, just be careful with those parentheses. Definitely put those parentheses around the negative 2 on that numerator. That's where you could easily kind of go wrong. But I went ahead and I plugged this in. I don't know if you guys have a calculator in front of you if you want to try or check, but it is 315. Mess up.
You wouldn't be able to do it.
You don't think?
No.
Mhm.
Too complicated.
Where's your calculator?
Over there.
So that's example 1. Example 2, very similar. They give us our A1, our R, and our N. So we're still going to use this first formula up top. So what is, so we're going to do S of 5. What are we going to plug in for A1? What's our A1? Well, they tell us, like, what are we going to put in our numerator, I guess, based on that formula? What?
81.
Okay, times 1 minus
1 minus R to the 1/3 to the 5th.
and probably a good idea to put parentheses around this R. I got the formula above, but it's a good idea to put those parentheses. I mean, sometimes, especially if it's positive, it won't really matter. But if you have a negative or a fraction, you got to put it in your calculator like that anyways. So then 1 minus your R, so 1 minus 1/3. So, I mean, it's up to you how you want to put this in your calculator. If you want to just, you'll definitely have to use a lot of parentheses. If you want to I usually just kind of work out the top and then I divide by my denominator. So this would be 81 times 1 minus 1/3 up to the 5th power, press equals. And then I would just do the mental math in my head. The bottom's going to be 2/3. Just divide by 2/3. As long as I didn't do anything wrong in my calculator, I got 121. But if you catch like an error, I would trust yourself more than me.
Mm.
But
Why?
Hmm.
You're the teacher.
Mr.
You're always
Swope, I trust you because I got 16.
you got 6
Yeah,
from where I
it's
notes.
it's fine. Things happen.
Let's see.
Hang on, I'm gonna try again.
Wait a minute. Wait a minute.
What if it was 16?
Wait a
No, how would you get
They
16?
got negative 121 in this answer key. They're wrong though,
Oh,
aren't they?
What?
How'd they get that? They had to have
What?
screwed up.
What?
Screwed up.
I'm scared.
I got it now.
Did you get
121.
121?
Mm-hmm.
Okay, because the answer key says negative 121, but they screwed up. Because they put the bottom as negative 2/3, but that's not right. 1 minus 1/3 is not negative 2. Okay, yeah, they screwed up. Okay. Who can you trust anymore? I don't know. So these next two examples, notice they give you really can pull out 3 things from this. You can pull out your first term. You can pull out your last term. A of n is like your last term. And you can pull out your R. What's your ratio? Like what's it multiplying each time to get to a new 3? If you ever can't see it too, remember you can always take like the second term divided by the term that came before it. That would give you it. But notice we don't know how many terms are in this sequence. Like I don't know that there's 50 numbers we're looking at. But some teachers would have you kind of like some work. You could plug it into the geometric sequence formula and solve for n and then plug it in. But I'm going to make your life a little bit easier. So if you're doing series and stuff, they might not give you the second formula. Like some textbooks don't only give you this first formula. They don't give you the second one. But it's kind of a nice trick. So you don't have to do a bunch of work to solve for your n, just to use the second formula. It is more memorizing though. Like, you know what I mean? If your teacher didn't give you these formulas on a test kind of thing. But we're going to be using this second formula though. So we have A1 minus AN times R over 1 minus R. So I'll write it down here just in case you don't have it written in front of you. So we're using this formula. All right, so just plugging in what we have, we would have S of n, because we don't really know how many numbers we have, but it's no big deal. We just want to find the sum anyways. We're not interested in finding the n at least. They're asking us to do. So we have 4 minus an, so 2,916 times our r, which is 3, all over 1 minus 3. So if you have a calculator, or if you just want to take my word, if you work that out, you should get 4,372.
That is a big number.
But I mean, if you think about it, I mean, I don't recall actually. I mean, I didn't figure it out for this, but going from 4 to 2,916, add in something that's tripling, I bet that's a pretty good number together. All right, but similar idea with D. It's the same kind of idea. So if they give you like the series like written out long form, you're going to want to use that second formula. Usually if they tell you, or you just know how many terms you have, you want to use that first formula. So what's our A1 in this problem D?
-6.
Okay, what's our A of n?
1,000. Oh, no. 122.
Okay, what's our R in this problem?
Negative. 3.
One thing, if you notice the signs are flipping, just know your R is going to be negative. So if it's plus minus, you have a negative R. Just be careful about that. So then just plug it into this formula. So S of n equals our first term minus our last term
I'm glad I have a good relationship with Christina.
minus negative.
You know,
I'm not muted, by the way.
So if you plug this in, as long as I didn't do anything incorrect in my calculator, I got 9,840.
Sounds wait.
And that's what they
Yeah, that sounds about right.
that's what they got on their key as well. So as long as we're both not wrong.
Sounds about right.
Okay. So that's kind of like the first big idea for today, is just calculating a sum of geometric series. Kind of, if you weren't here yesterday, that's kind of what we saw. We looked at arithmetic. That was kind of our idea, finding the sum of an arithmetic. The next thing we're going to look at today, though, is infinite geometric series. So
What?
basically, if you have a series that kind of goes on forever, like you're summing up something that goes on continuously, like, for example, if you kept cutting something in half forever and just kept adding it over and over again, what would you get?
Infinity.
You're going to see it won't always be infinity. Because if you think about it, if you, like, for example, this first problem we're looking at, it starts with 4 and it adds a fourth of the term that came before it each time. We're going to see, you might be like, well, if you keep adding something to something, won't it equal infinity? We're going to actually see it's going to converge. It's going to get closer to a value. So let me kind of demonstrate that. Let me move this out of the way. I don't know if you guys see that on the video or not. But if you look, the S1, the sum of the first number would just be 4 from this series, right? S2, like add in the first 2 terms, you get 5, right?
Yeah.
You take the first 3 terms, you get 4 plus 1 plus 1/4 is
5.25.
And I'm not going to have you do like all these by hand. I have an answer key here, steady. But if you kept plugging these in your calculator, I'm just going to write what they equal. This next one, you're going to see it's 5.3125.
Whoa.
The sum of the first 5 terms would be 5.328. I went ahead and did these just so you don't have, I mean, if you plug these in, you'll see that's how I'm getting these decimals. This next one's about 5.332. S of 7 is about 5.333.
Right.
This one's about, here, I'm going to add another decimal place just so you can see this is different. This one's about 5.332. This one's about 5.3333. So you see, like, especially when I get further along in this series, the more terms I add, it's really not making a big difference, right? And obviously, I'm kind of the decimal. It's slightly changing, but you kind of see it's like approaching a value. So we would say that our S of n for this series, even though we don't have an exact answer, it's approximately equal to about 5.3 repeated.
5 1/3.
So what appears to be happening, what I want you to notice, is we say this, what appears to be happening is that the sum is leveling off, or it's like it's approaching a value.
But asymptote stuff.
Kind of, yes. This, I guess I'll say the sum is leveling off at.
Plateauing.
So basically, it's approaching a value, because it is kind of counterintuitive, because you might first think, well, if you keep adding something, won't it just go to infinity? But this case, it's not actually going to infinity. I guess in theory, if you kept adding things forever, yes, it would grow, but it's growing so slowly, it's really convergent. It's just going to get closer and closer to this value. It's really not going to go to infinity. Because if
I
you
see.
look like at these terms, like each one you're adding, like the difference between S8 and S9 is you're adding 1 over 16,384. That's very, very small, and it's only going to get smaller. For example, if you found S of 50, and if you don't believe me, you're welcome to do it using the formula. If you found the sum of S of 50, you're going to see it's like 5.33333. Like it's going to be like nearly identical to these previous results. It's not really going to change too much. So we say that this is an example of a series that converges. Basically, it gets close to a value. So how can you tell this is going to happen? Really what you want to look for is if your R value is between -1 and 1. Because what was our R value in this problem we just looked at?
1/4.
So we saw that our R value above was 1/4 because it was 1/4 smaller each time what we were adding. So that's why it's this case. So you'll see the terms diminish rapidly and the sum starts growing by negligible amounts. S approaches a finite sum in actual numbers. So this is called a convergent series. So if you ever hear the word convergent, because if you do end up taking a lot of upper math classes, usually in calculus 2, at least when I took it, you do stuff with series and you talk about if it's a convergent or divergent. So you'll hear these terms possibly, depending on where your kind of trajectory goes with your math classes. Or you might never hear it again. And but
Who knows?
the other case that can happen though is if your R is greater than 1 or less than -1, we say it diverges. Because say for example you had a series like this, it doubles every time, like kind of like that example we saw earlier. If you keep adding numbers that double, that's going to approach infinity. It's just going to keep getting bigger and bigger. So this one you would see it approaches infinity, while this one we looked above approaches like this 5.33. So it diverges if it goes, it just keeps growing forever, like X's and check marks. Converges is when it gets closer to a number, but it's all based on your R value. That's really what you want to be looking for. Okay? So let's look at some examples of these infinite series. So it says example 3, sums of infinite geometric series. Does the infinite geometric series converge or diverge? If it converges, find the sum. And over here on the right in this box, there's a nice formula to figure out what it converges to. Instead of listing all the sums like we did in that previous example to see what it got closer to, this formula will give you that result without as much kind of checking yourself. But you could list out a bunch of like sums if you want to see what it gets closer to, but we'll see. Wait, what? Oh, okay. Wrong thing. All right, so first thing we want to like determine with the first thing you want to look at when you're looking at an infinite series is just figure out one. I mean, all of these ones are, I believe, we'll see if they threw anything, but I believe all these are geometric. But one, if it's not geometric, that's something to be on the lookout for. Another thing, but really what we want to find is our R value for all these to determine if it's going to converge or diverge. That's the first thing you want to figure out. So for example, on part A, what would your R value be? How do you go from 18 to -9 to positive 4.5? What do you multiply by? Or what's happening to the numbers?
-1/2.
So it'd be like half. So if you're dividing, but you really want to write it as a fraction if you're divided, so it would be -1/2. So I know you don't have this in front of you, but looking above, -1/2 would fall in this case too. So that's going to converge. So we're going to use this formula. So first off, this does converge. So we want to figure out what it converges to then. So we're going to use this quick little formula. Like I said, you could keep listing out like sums and kind of see what we did above, but this formula is just kind of a shorter way or a nicer way to do it. So you take your first term, so 18, divided by 1 minus r, and our r we said was -1/2. Or in other words, we really have 18 over 3 halves or 1.5. So if you put that in a calculator, 18 divided by 1.5, what do they get?
12.
So this would converge to 12. So like if you kept adding more and more terms, you would see it's going to get closer and closer to about 12. Okay? The more terms you add, the closer it should get. All right?
All right.
What about B? What's our R value for B? How do you go?
Negative 1/3.
Mhm. So once again, it's a fraction. It's between -1 and +1, so that is going to converge. So we want to use that formula. So just it is this A1 over 1 minus R. So 18 over 1 minus 1, -1/3, or really plus 1/3. So that would be 18 over 4/3, which is a 27. So this converges, sorry, this is a little sloppy, but this second one converges to 27.
Does it now?
Why?
Wait, let me see something.
I'm going
All
off.
right.
Did I screw someone up? 18 divided by 4. Wait, no, if you divide 18 by 4/3, is that wrong? If you're dividing 18 divided by 2, it should be getting smaller.
It should be getting smaller.
That's
I
wrong.
got 13.5.
Yeah, me too.
Sorry, their key's wrong. I just trusted their key over here. But yeah, you're right. If you're dividing by something bigger than 1, it should get smaller, not bigger. I'm guessing maybe they did 3/4 on accident. So you got 13.5 though? Okay. Yeah, I did. When I was looking at that, I was like, can't trust yourself, trust them, but I was wrong. All right. Thanks for catching that, Eva. This next one. What's our R value? This one's hard to like look at and see it. All these ones before you can kind of look at it and see. Remember,
5 points.
one way you can check for an R value is take your second term divided by the term before it. So 5/4 divided by 1 is just going to be
1.25.
yeah, or 5/4. R value is 1.25, right? So
it's not easy.
so that's bigger than 1, right? So that's going to diverge. So we're not going to find where it converges to because it would converge to infinity technically, but we say it diverges when that happens.
You ever seen Divergent, Mr. Swope?
I have not.
Okay.
What's it about, actually? I've never...
It's really good. So like, there's this girl, and there's like these different factions, and to sum it up, there's like intelligence and like trust, like all different types of like things in people's brains, and then kindness. But then she's like all of them, but she's none of them. But you should watch it.
Good movie.
It's really good.
I'll see.
What's his name? 4?
Ooh, 4, and yeah, you should watch it.
Is it on Netflix? I wonder.
No, maybe try Hulu or something. I don't know.
We'll see. All right. D, what would our R value be? Is it C? Worst case, you could take the second term divided by the first term.
Is it
1/3.
It is 1/3. One thing to be careful about, all of these problems, we're kind of assuming they are geometric, right? If
Yeah.
they didn't tell you they were geometric, you'd want to make sure that this R value like holds true. You know what I mean? Just make sure it like 81 to 27 is 1/3, 27 to 9 is 1/3. Just double check yourself because it might be like arithmetic or weird or not fall into like one of these patterns. So that is one thing just to be careful about. I mean, I don't think I'm going to do anything like that on your test per se. No, I don't think, no, I won't, because we didn't really do anything else. But I'm just saying that is one thing just to be kind of careful about. But usually, I mean, that's not going to come up. But in theory, I guess it could. So just be careful, I suppose. All right, so this means it does converge. So we'd use that formula. So A1 over 1 minus our R. So 81 over 2/3. Let's see what they got. They got 121.5, which at least it makes sense. It should get bigger. You're welcome to double check. All right, what about E? How do we figure out our R value? So it's not one you can kind of look at. See, one way you can find your R value is take your, I mean, it doesn't matter what term, but take like a term and divide it by the term that came before it. So I'll do the second term.
It'd be bigger than 1, wouldn't it?
Yes. It's about, what did they get? 1.04. But you're right. It doesn't even matter what it is because it's going to be bigger than 1. So that means it's divergent.
Wait, what?
Basically, if you keep adding things like this, it's just going to get bigger and bigger. And it would, in theory, the more and more you do it, it's just going to get closer to infinity.
Yes.
Okay. So that's infinite series. So basically, you want to just check what case it falls into. And then if it is convergent, you can use this quick little formula to find it. But if you ever forgot this formula, like you're on a test next year and you're like, oh, shoot, I'm screwed, you could keep listing out different sums of different terms and see what it is getting closer to. So, I mean, that's one way you can kind of verify yourself if you're like really unconfident in your answer. But I don't know how much you'll do with this next year. I don't really know if they do a lot with it. I think they do some, which because I almost skipped this section last year. Why are you guys laughing at me?
Because you said doo-doo. My goodness.
So that's kind of the main ideas. If you want to see this last little bit, basically, how can you change repeat and decimals to fractions? How do they do it on their key? Let me see. I don't know if I don't think. Let's see what they do. I've seen different ways to do it. Oh, there's the home. All right, I'll give you example 4. To be honest, I don't think you'll see one like this on your test. Maybe I'll put a bonus. I don't know. I don't know how ambitious I am. I've been pretty lazy. To be honest with you. But so let's say we have a repeat in decimal and we want to change it into a fraction. Well, first off, this is really this. Another way you could write this, though, if you kind of wrote it as a write it as a geometric series. So just kind of like what we did above, we need to find our R value. So our R value, we could take the second term divided by the first term. And it'll be your calculator. If you plug that in, though, you get about 0.01.
So 1 over 100. No, wait.
So you would take your first term over 1 minus your R. To figure out where.
Oh, okay.
If you work that out, it would be running out of space. 0.52 over 0.99, which is really just 52 over 9.
That makes sense.
So I don't know how, like, there's different ways you can do things with fractions too. If well, I guess if it's not repeated and stuff. There's other ways you could do it. I've seen other methods. So you don't have to do like a series. But
Put the shepherd in the wrong way. It's supposed to go in there. But it goes on
I like all the drawings. I'm sure people watching the video will appreciate them. How do I stop?